All right. So, welcome back. Today we're going to talk about AWS Batch. But before we get started, hit the like button, subscribe, and share with anyone you know taking the AWS Machine Learning Associate exam. So, AWS Batch is a fully managed serverless batch computing service for running hundreds to thousands of batch processing jobs. Unlike Glue's focus on Spark-based ETL, Batch provides generalized infrastructure for any containerized workload running asynchronously and independently. Jobs running from Docker images submitted to job queues. AWS Batch automatically provisions and manages underlying compute. That means EC2 on demand or spot instances based on the queue priority, resource requirements, and availability. The core principle, non-real-time containerized workloads that can parallelize or queue are strong batch candidates. So how does this work with AI and machine learning? So batch suits several machine learning pipeline stages. Preprocessing and cleanup jobs handle large-scale S3 scans or data validation. Model training jobs that don't require SageMaker can containerize and run through batch. Hyperparameter tuning workloads treat each configuration as a separate job. Inference pipelines process batch predictions over large data sets. Simulations for Monte Carlo analysis in finance or bioinformatics leverage batches parallelization. Batch provides granular environment control via Docker and full AWS SDK access inside containers, making it versatile for DevOps and machine learning engineering. So let's see some architecturing. Okay, so Batch eliminates cluster orchestration management through serverless provisioning that automatically scales EC2 or spot instances. Container-based execution runs jobs from Docker images, custom or public. Flexible orchestration integrates with CloudWatch events and step functions. Resource-level control lets each job request specific vCPU and memory allocations. And VPC access enables jobs to interact with S3, RDS, and other resources. So let's see. There's a little more about the configuration. So, okay, so batch versus glue. All right. So batch handles general purpose batch computing in any language via Docker, with jobs running in containers and high resource control. AWS Glue specializes in ETL and data transformation using Python or Scala Spark jobs with abstracted infrastructure. Batch schedules through CloudWatch events and step functions, while Glue uses triggers and workflows. Both are serverless, but Batch suits non-ETL batch tasks, simulations, and cleanup jobs, while Glue transforms structure and semi-structured data. So what's the cost structure here? And this will go into, yeah, this is a little more specific, right? All right, so cost structure. So batch itself is free. You pay for underlying resources. That means EC2 or spot instances bill per instance, per hour, based on the type. EBS volumes add costs. If attached, right? So data transfer between VPC and S3 may apply. So your best choice is to use spot instances for savings on fault-tolerant workloads like model training or cleanup scripts. So how do you set up batch? Let's go in here. All right, so first thing you want to do is configure an IAM role, right? Make sure it has the job definitions for the AWS batch service. You're going to use the AWS batch service role for batch to manage the resources, and then an instance role for EC2 workers. So you can have an EC2 container service for the EC2 role. All right. Then you're going to go into batch. All right. So let's see. Batch. All right. Let's see. Compute. All right, so it looks good. All right, so we're back here. Get started. All right, so from here, you're going to want to create your managed environment. So you're talking about compute, Fargate, compute, or EKS. All right. Okay. You have your name, your instance role, which we don't have. We didn't create one. That's fine. The configurations. So you have your minimum, your desired, your maximum. Okay. Allowed instance types. So it's like the C4. Okay, those are going to be pretty large. Your VPC, which is it's set to the default, which you really don't want to do. It's not going to let us go because we don't have the instance role, right? Create the job queue, right? So this will set the priority. So you can have this set for testing. You can associate your compute, and then just name it. And then you define your jobs right here. Define your jobs, right? And then you select the EC2, name the job, specify the Docker image, and then you set some commands like how to run the script, like user/bin/python3 script.py, right? And then you could attach environment variables, IAM roles, mount points, or volumes. And then you create that job and you go. All right. So within this, you'd be able to monitor the status as it transitions from submitted to succeeded or failed. All right. So we're going to go back out here. All right. So what's the practical portion of this? All right. Consider a trained model stored in S3 needing batch predictions. You could package a script that pulls a large CSV from S3, load the trained model job using joblib or pickle, and then run inferences for each row, write predictions to another S3 location, and then build this into a Docker image, push it to ECR, create a batch job definition, and then submit this periodically or via step functions. So this architecture can scale to thousands of inference jobs without managing that infrastructure. All right. So for the exam, remember a couple of things. When questions are asked about running containerized batch workloads, processing large data sets asynchronously, or orchestrating parallel jobs without managing infrastructure, batch provides the managed service bridging fully managed offerings like Glue and custom concentrations for orchestrations on ECS or EKS. So before we get out of here, hit the like button, subscribe, share this with anyone you know taking the AWS Machine Learning exam. Until then, thank you for joining and have a good day.